Okay, here's our sum and difference formulas. So, what if we need to find the sine of 105 degrees? Well, 105 degrees is not on the unit circle, so we need to come up with a different way to calculate that. And that's why we have sum and difference formulas. So what we have to do is we have to come up with some way. We could either rewrite 105 as the sum of two values or the difference of two values that are on the unit circle. So let's take, for example, 45 degrees and 60 degrees. Okay, those two have a sum of 105. So we could use that combination. We could also take 105 and make it the difference between two angles on the unit circle. So let's say 150 minus 45. And we know 150 is one of our angles on the unit circle, as well as 45. So that's what we're going to be looking at today. So let's look at our sum and difference formulas. So for sine, if we take sine of 105 minus 45, the A angle would then be 150, and the B value would be 45 degrees. So if we expand that out, we're going to take the sine of A, which is 150, times the sine, or cosine of B. Well, B is 45 degrees, minus the product, which we're going to multiply those together, the cosine of A, and A is 150, over the sine of B, and we know that B is 45 degrees. So that's how we would expand the difference formula, using values off the unit circle. So, and then we can just evaluate that, and we're going to do those in a minute. Okay, now the sum formula is very similar to that. Let me grab all this and slide it over. It's sine A cosine B plus cosine A sine B. So everything is the same except for literally the sign. So this is going to be a positive. And how I always teach it is sine's formula is sine, cosine, cosine, sine. Same sign. And that last sign is SIGN, the fact that we're subtracting. Therefore, this is subtracting. And the same with the sum formula. Sine, cosine, cosine, sine, same sign. So that's how you can remember the sine formula. Okay? Now, this one's kind of tricky because we need to talk briefly about the distributive property. So, does the distributive property hold true for functions? So if we have f of x plus 6, is that the same thing as f of x plus f of 6? So if I take a value of x and I add 6 to it, am I going to get the same output as if I evaluate f of x, whatever x is, and then I add the value of f of 6? And I hope you're saying, no, that is not true. So the distributive property, well, if we distributed that in, does not work. That's why on this one, the sine of A minus the sine of B is not sine A minus sine B. That would be applying the distributive property to this sine formula, and this is not true. So when it comes to functions, that's not true. Okay, and we can show you with an example. So here's sine of 2 pi thirds plus 5 pi 6. We're going to evaluate it using the sum formula. Then we're going to look at the sine of 2 pi thirds and the sine of 5 pi 6 and see what that is. And we're going to compare them to see if it is indeed true or false. So let's evaluate this using our sum formula. So I'm going to expand this with sine of 2 pi thirds times the cosine of 5 pi 6. And I'm going to add to that the cosine, right, of the first angle, which is 2 pi thirds, times the sine, the sine of 5 pi 6. And let's evaluate that off the unit circle. So if you need to, you can grab your unit circle. We can look at this. Okay, sine of 2 pi thirds, that is a root 3 over 2, times cosine of 5 pi 6, that's right here, and that is negative root 3 over 2. We're going to add to that the cosine of 2 pi thirds, which is negative 1/2. And we're going to multiply that to the times the sine of 5 pi 6. Well, the sine of 5 pi 6 is positive 1/2. So let's multiply all that together. That's going to give me negative root 9, which is 3 over 4. And I'm going to add to it actually a negative 1/4. So that's going to be plus a negative 1/4. Well, that ends up being negative 4/4 or negative 1. So there's the actual answer. Well, do we get the same thing if we evaluate as if we've distributed that in? Well, let's try it. Okay, so what's the sine of 2 pi thirds? Well, we actually used it over here. Okay, the sine of 2 pi thirds would be, and I'll try to slide this down so you can see it. The sine is root 3 over 2, which hopefully by now you have that memorized anyway. We're going to add to it the sine of 5 pi 6. Well, 5 pi 6 is 1/2. So if we add those together, we just get root 3 plus a positive 1 all over 2. And that value is not 1. So guess what? These are not equal. Therefore, you cannot distribute. It supports the fact that this is a no. They are not the same thing. Okay? So what are our sum and difference formulas we're going to work with in this lesson? We're going to work with the sum of cosine and the sum of sine. We've already looked at the sum of sine, and it's sine, cosine, cosine, sine, same sign. But cosine of the sum is a little bit different. It's cosine, cosine minus sine, sine. So it's cosine, cosine, sine, sine, opposite signs. And the same thing's going to work for the difference formula. Sine is sine A, cosine B. So sine, cosine, cosine, sine, same sign in the middle. But cosine is cosine, cosine plus, so it's the opposite sign of sine, sine. So you multiply the cosines together, multiply the sines together, and it's the opposite sign. And then tangent's got its own pattern. Tangent, you're going to take the tangent of A plus the tangent of B. So it almost looks like you do distribute it, but then you're going to divide it by 1 minus their product. So whatever you get up here, you're actually going to subtract that product from 1. Okay, and then for tangent of the difference, it's tangent A minus tangent B. So notice the numerators are the same, but what do we notice about the denominators? They're the opposite. So this will be tangent A times tangent B. So tangent is the same sign on top and the opposite sign on the bottom. You apply the operation to the tangent of A plus or minus on top, the tangent of B, and then 1 minus or plus the product of tangent of A times tangent of B. Okay, keep those formulas handy because we're going to use those to evaluate now. So find the sum or the difference from the unit circle of the value 5/12. So we need to come up with two angles that are on the unit circle that add or subtract to 5 pi 12. because 5 pi 12ths is not on the unit circle. But we could take 5 pi 12ths and divide it into two parts. We can rewrite that as the sum of 3 pi 12ths and 2 pi 12ths. That's 5 pi 12ths. Okay, now we don't recognize those because they're not reduced, so let's reduce those. Okay, 3 pi 12ths is really pi 4ths, and 2 pi 12ths is really pi 6. So there is our sum of the two angles. So let's write this out. So we have the sine of pi 6 or pi 4ths plus pi 6. Okay, so now I'm going to expand this using our formula. Now sine is sine, cosine, cosine, sine, same sign in the middle. So this is going to be sine of pi 4ths times cosine of pi 6 plus, same sign in the middle, cosine of pi 4ths times sine of pi 6. Now, let's use our unit circle, if you need it, to evaluate those values. So, get comfortable again with the unit circle. Remember a while back I said, it never really goes away. Okay, so here it is rearing its head. So sine of pi 4ths is just root 2 over 2. Cosine of pi 6 is square root of 3 over 2. So the first portion of this is the product of those two values. Plus, well, the sine of pi 4ths is the same as the cosine of pi 4ths, which is just root 2 over 2. And then the sine of pi 6 is a half. And we're going to find that product. So what is that? Once we multiply and add, what do we get? We get a root 6 all over 2 plus a root 2 all over, my denominator is not 2. My denominator is 4. 2 times 2 is 4. Sorry about that. And then root 2 over 4. And then, so our final answer is root 6 plus root 2 all over 4. Now, I want you to think, can you simplify that? And the answer is no. Root 6 does not add with root 2. The radicals have to be the same in order to add those together. And they're not divisible all by 2 because the 4 is not in a radical, so you're done. It's just root 6 plus root 2 all over 4. Okay, I'm going to move this answer over here just in case we need to erase a little bit and make some more room for the next problem. Oops, it's supposed to be an eraser. There we go. Now let's try the same thing with the cosine formula. So we're still going to find the cosine of 5 pi 12ths. We're just going to do that by rewriting it as the cosine. So let's go ahead and write it like that first. So what's the cosine of 5 pi 12ths? Well, we don't know that from the unit circle, so we're going to rewrite this as the sum of pi 4ths plus pi 6, because those two angles add to 5 pi 12ths. Now let's expand our cosine formula. Cosine works like this: cosine, cosine, sine, sine, opposite sign in the middle. So we're going to write this as cosine of pi 4ths times cosine of pi 6. Opposite sign, so minus sine of pi 4ths times sine of pi 6. Okay, and again, you can use your unit circle if you need to. Hopefully, again, we're weaning ourselves off that. But cosine of pi 4ths is our root 2 over 2 times the quantity of cosine of pi 6? Well, that's just root 3 over 2 minus the quantity sine of pi 4ths. That's root 2 over 2. And sine of pi 6, that's a half. So we end up with the quantity. Well, the first term is going to be root 6 all over 2 times 2. I won't do it this time. That's 4 minus root 2 all over 4. So if we clean that up and just put those together, we're going to get a root 6 minus a root 2 all over the quantity 4. So as we said earlier, we can't simplify that, but I want you to notice these two answers. They're very similar. One's addition and one's subtraction. It just ends up that way. There's always a little pattern to those. Okay, so now let's try the tangent. So we want to find the tangent of 5 pi 6. I'm sorry, 5 pi 12ths. And we're going to rewrite it how? With the sum of the two angles. So tangent of pi 4ths plus pi 6. Now our tangent formula is a fraction, so that makes it a whole lot trickier. Okay, so on top, we're going to write it as tangent of pi 4ths plus tangent of pi 6. So it looks like we just distributed that on top. And then on the bottom, it's always 1 and then the opposite sign. So 1 minus their product. So this is going to be still the tangent of pi 4ths times the tangent of pi 6. So let's see if we can figure this out. So on top, let's go back. What is the tangent of pi 4ths? So again, if you need your unit circle, just bring it down. Let's look at it. Tangent at pi 4ths, that's, hopefully you remember that, that's just 1. Plus, what else is on top? Tangent of pi 6 right here. Well, we know that's a root 3 over 3. Okay, and then on the bottom we have 1 minus the product of those two. So the tangent of pi 4ths is 1 times root 3 over 3. So let's just kind of clean this up a bit. So we have 1 plus root 3 over 3 all over 1 minus root 3 over 3. Okay, now don't think that you can just, oh, I'm going to cancel my 1's out. No, 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 no. This is one quantity and that is one quantity. They're totally different. And you cannot, you can't cancel anything out here. We can get common denominators and combine the top and the bottom. So I'm going to now combine the top to 3 plus root 3 over 3. Now, hopefully everybody knows what I just did. I just multiplied 1 by 3 over 3 to rewrite that as 1 and then added the numerator. Then on bottom, I'm going to multiply this by 3 over 3. That's going to give me 3 minus root 3 all over 3. Now, hopefully by now, you know some of the tricks of the trade. When you have the same denominator in the denominator in this complex fraction, these are the same, you can just cancel them out, right? So you end up with 3 plus root 3 all over 3 minus root 3. And often you can stop right here, but I beg to differ, and I like to clean this up, so I do not have a radical in the denominator, okay? If you remember from Algebra 2 how we handled these, we multiplied these by their conjugates. So I'm now going to take this 3 minus root 3 and multiply it by 3 plus root 3. So I can clean that denominator up to a whole number. Okay, I like to do this for many reasons. One, you just need to know how to do that. So it just reviews it. And then you don't ever want to have a irrational number in your denominator, at least at this point in mathematics. Okay, now let's FOIL this all together. So first, outer, inner, last, do all the multiplying. We end up with in the numerator 9 plus 2 square root 3 plus 3, which ends up being 12 plus 2 root 3. Okay, and then on the bottom, we end up multiplying together. First is 9, outer is positive root 3, or positive 3 root 3, inner is negative 3 root 3, so they cancel. That's what a conjugate does, minus the quantity 3. So I get a 6. Now, this looks like we're almost done, but what are we missing? We can simplify this answer. Okay, so let's go one more step and just divide everything by 2. So I'm going to get a 6 plus root 3 all over 3. And that, my folks, is our final answer. And we finally got there. Okay, so let's look at tangent one more time, because tangent is by far the trickiest. You start with your angle. You rewrite it as the sum of two angles. Then you plug it into your tangent formula. Tangent is the sum on top, and since this is the sum is on top of the tangent of the first angle plus the tangent of the second angle over 1 minus their product. Then we plug in. Once we get to here, we just make a complex fraction. So add the numerators together, add the denominators together, and then we just clean it up. So there you go. That's how we work all the way to this final answer. And then, of course, we had to multiply by the conjugate to make it look pretty. So that's just plugging into the values, but there's far more to this concept. We can do identities with these sum and differences. So let's try an identity. Okay, so we're going to verify this identity. And it's cosine of x plus y times cosine of x minus y. Well, what we have to do is we have to apply the sum and difference of cosine into these angles. So I'm going to expand these out. So cosine of x plus y is going to be cosine x times cosine y. Okay, and it's always the opposite sign of sine x and sine y. Okay, so there's my first one. That's the first one expanded. Now let's expand the second one. This is going to look the same, only the sign in the center is going to be opposite, right? So I've got cosine x, cosine y, plus sine x and sine y. Now, once I get to here, what do? Well, we've got two binomials. So what becomes natural here? Well, what becomes natural is multiplying these together, FOILing it. Well, these are conjugates. So you're going to end up first times first and second times second. And then the outer and the inner are going to cancel. So let's just multiply first together. So we're going to get cosine squared x cosine squared y minus sine squared x times sine squared y. There we go. We just FOILed that together, and this is where we ended up. Well, that's not the identity. But is there anything else? Whoops, I forgot my x in here. Is there anything else we know? Well, sine x minus sine y. Is there anything we could do here? I'm not seeing it. I really am not seeing. So we're going to come back and visit this in a minute. Okay, so what's the ratio of two sides of triangles? What we're going to do here is we're going to find the cosine of the difference of two angles. When we find the cosine, the difference of two angles, we have to have these angles represented somehow. So what we're going to do is we've got an angle A, we have a ratio provided, and we also have a quadrant provided. So what we're going to do is we're going to draw this triangle in this quadrant. So if cosine of A is equal to -8/17, we are in quadrant what? Well, what's pi to 3 pi halves? That's going to be quadrant 3. I'm then going to draw my reference angle. We know reference angles come out of the origin and go back and touch which axis? The x-axis. So there's angle A. Now, if cosine is -8/17, I'm going to label my triangle with a -8 on the x-axis, 17 as a hypotenuse, and I hope you know your triple. This side will be 15. Okay, so there's the triangle we're working with based on this angle A in quadrant 3. Now, since this is quadrant 3, we know the 15 is also going to be negative because the coordinates here are negative, negative. Okay, now let's look at the second one. Okay, we're looking at the sine of B. So we have a second angle B. And B, we have to draw it. Okay, which quadrant are we in? We're at 3 pi halves to 2 pi. Okay, that means we're in quadrant 4. Going to draw a reference angle, and what do we know about the reference angle? It comes out of the origin and it touches the x-axis. So there's angle B. Now, the sine is opposite -4, hypotenuse 5. Now, hopefully you recognize this triple, and we know that this direction is 3. Is that a +3 or a -3 in quadrant 4? Well, we know that's a +3 because it's the positive direction, positive x direction. So now that we've got the triangles drawn, the next thing we're going to do is expand this out. So for cosine, we need to know that it's cosine A, cosine B, opposite sign, so plus sine A times sine B. Now we're going to use our triangles to evaluate all of these. Okay, so let's start with the cosine. Cosine of A. Well, cosine of A was actually given to us. It is -8/17. And that makes sense because it's adjacent over hypotenuse. We're going to take that and multiply it by the cosine of B. Well, this is B, and what do we know cosine is here? Adjacent over hypotenuse, so 3/5 plus sine of A. So we're going to go back to the first triangle because that's angle A. The sine is -15/17. And we're going to multiply that by the sine of B. So go back to the B triangle. And sine of B was given to us. It was -4/5. And there we go. Now we just need to clean this up. So, whoops, I'm not quite ready for cosecant yet. I'm going to multiply this together, and I get -24 on top in the numerator, and 5 times 17, 5 times 35, carry the 3, so what's that, 85? Okay, 85 plus, and then a negative times a negative is a positive, and 4 times 15 is 60 over, and then again 17 times 5 is 85. And now they have a common denominator, so all I have to do is subtract. And 60 minus 24, that's going to give me 36/85. And that is my final answer. That's the cosine of A minus B. Wow, that's a lot. Okay, so what did we do? We wrote out the first, we drew the triangles, right, in the correct quadrants, making sure our signs, S-I-G-N, are the right sign. Then we wrote out the cosine formula and plugged it in based on which triangle we were using. Now, what would we do if we're finding the cosecant of the sum of two angles? Well, I hope you're thinking, well, there isn't cosecant formula, but we do know a sine formula. And we know the sine and cosecant are reciprocals. So what we're going to do is we're going to evaluate this as a sine, as a sum of two angles of sine. Then we're going to take the final answer and we're going to find the reciprocal. So let's write out the formula for sine. It's sine A times cosine B, same sign, so adding cosine A times sine B. So it's sine, cosine, cosine, sine, same sign. Now, let's go back up and evaluate. So, the sine of A, here's the A triangle, and the sine is -15/17 times the cosine of B. Well, let's go to the B triangle. Mind the cosine. The cosine is 3/5. So times 3/5 plus the cosine of A. Let's go back to the A triangle. Cosine is -8/17. That was given. Times the sine of B. Sine of B is -4/5. That too was also given. Now, let's just evaluate or simplify those. And that's going to give me -45/85 plus two negatives make a positive, so 32/85. Same denominator, so that makes it nice. What's our difference? It's 13, so -13/85. And that right here is my sine of A plus B. Now, we didn't want the sine. What did we want? We wanted the cosecant. So what are we going to do? We're going to take its reciprocal. So the cosecant of A plus B would then be -85/13. And there's our answer. So yes, I have the negative with the 13, and you can write it as 85/-13, but typically we just keep the negative with the numerator up top because the term is negative. That's just a term. So there we go, and that's how you'd evaluate those sums. Okay, so this is actually a step back, makes it a little easier. Can you do this? Do you recognize that word? Can you do it backwards? Yes. Can you do it backwards? This is the word backwards that's written backwards. Can you do this backwards? In other words, can you look at an expansion, decide which equation it is? Is it the cosine? Is it the sine? Or is it the tangent? Do I add? Do I subtract? What would it look like? Okay, so let's look at the first one. We have cosine 30, cosine 225 minus sine 30, sine 225. Well, is this the cosine or the sine formula? And I hope you're going, oh, cosine, cosine, sine, sine, that's the cosine. Yes, indeed, that is cosine. But when you expand it, it's always the opposite sign. So we're going to end up adding these two angles together. So 30 plus 225. That just adds to, what's that, 255? 255. So really, what are we evaluating? We're evaluating the cosine of 255. That's all we're doing. We're looking at the formula, seeing if it's the sum or the difference, and then like squeezing it back together and deciding what it is. So let's look at the second one. The second one is sine 60 cosine 150 minus cosine 60 sine 150. Okay, well, looking at this, we know it's the sine formula. So sine keeps the sign. So it's going to be A minus B. Don't be tricked. Be very careful. This is the sine of the A angle. Angle A is 60 minus 150. And sine keeps the sign, so we are indeed going to subtract. We're going to subtract those two, so it's going to be the sine of 60 minus 150. That's negative 90. So, yeah, it's okay that it's negative. That's okay. Okay, so that's where this one comes from. Okay, now let's go back, do a little erasing so we can look at this last one and have our formulas right here on the same page. Now we need to look at this last one. First, is it a sine or a cosine formula? Cosine, cosine, sine, sine. I hope you're going, oh, yeah, that's cosine. Okay, cosine, and that's going to be, the two angles are 60 and 45. Now I want you to think, okay, cosine, it's addition here, but what do we know about cosine? It's always the opposite sign, so we're going to subtract. So 60 minus 45 is cosine of 25 degrees. Bingo, right? No, 15 degrees. Yeah, it's just 15 degrees. 60 minus 45 is 15. So it's a cosine of 15. So you could evaluate the cosine of 15 with this expansion. And there is our answer. And that's all we're looking for, is to condense it back together. Now, verifying a second identity. Let's go ahead and try this one. I really like these. These expansions make a little more sense. Okay, we're going to verify this identity by expanding a sine and by expanding a cosine. Okay, they're both the difference, but we know that sine will keep the negative and cosine is going to change that to a positive. So let's expand these. Okay, sine of x times cosine of pi thirds. Same sign, so minus cosine pi thirds times, cosine of x times sine of pi thirds. Okay, we're going to take that, we're going to add to it this expansion. This expansion is cosine times cosine. So cosine of x times cosine of pi 6. Now we need to change this sign. So it's going to be another addition sign. Sine of x times sine of pi 6. Now, let's evaluate the ones we can. We know that cosine of pi thirds we can evaluate. Sine of pi thirds, and then cosine of pi 6 and sine of pi 6. All those can be evaluated. So we're going to have a coefficient that's then going to go in front of this. So what is the cosine of pi thirds? Well, that is a root. Cosine of pi thirds is a half. 1/2 of sine x minus the sine of pi thirds is root 3 over 2 times cosine of x plus cosine at pi 6, that's a half, right? No, that's a root 3 over 2. It's late in the day. And then plus sine of pi 6, that's just a half. sine x. Okay, so let's look and see what we have. We have a half of sine x, negative root 3 over 2, cosine x, positive root 3. Oh, these cancel. Then I have a half sine x, a half sine x, a half and a half make one whole sine x. That indeed equals sine of x. So, bingo, we did it. And there is verifying that sum and difference. Okay, so let's take one more little stretch here. We're in the home stretch. Okay, hang in there with me. And you can take a break anytime you need to. But we're going to evaluate the cosine of these two angles. So I want you to think for a second. When you take the inverse of a ratio, doesn't this represent an angle? And the inverse of a sine of 2x, that's an angle. So we're taking the cosine of an angle plus an angle. So this is the sum of two angles. Okay, well, let's write this angle out in the triangle. So I'm going to use this as my angle, my reference angle. We'll call that theta 1. Okay, so theta 1, my cosine is x. That means this is x. My hypotenuse must be 1. And what did we learn in one of the other units? That the hypotenuse, or the opposite side, we're going to use the Pythagorean theorem. I'll call this side that we're looking for b for a second. Okay, is equal to 1 squared, Pythagorean theorem. So b squared is equal to 1 minus x squared. So this side b is equal to either plus or minus 1 minus x squared. Now, if we're not given a quadrant, we're going to assume we're in quadrant 1. So there's our first triangle. We're going to do the same thing over here. The second angle, so this is like theta 2, and this is theta 1. We don't know the angles, but we know we've got a ratio of those. Okay, so theta 2, we have a sine. And for sine, that's your opposite over your hypotenuse. Well, the hypotenuse must be 1. So what do we know this adjacent side is? Using the Pythagorean theorem, it's the square root of 1 minus 4. Remember the 4, we had to square that, x squared. If you couldn't remember that, you can do, well, a squared plus 2x squared is equal to 1 squared. And then work from there to get a. And the a ends up being 1 minus 4x squared. And then you have to take the square root of all that. So that's where it comes from. Okay, so now we have our triangles drawn. Now we need to expand the cosine formula. So, it's going to take a little bit. So we have to take cosine is cosine of the first angle. I'm going to call this theta 1. Oops, theta 1 times cosine theta 2 minus, because it's opposite sign, sine theta 1 and sine theta 2. Now, let's plug in what we know. Cosine of the first angle is just x times cosine of the second angle is root 1 minus 4x squared. All minus sine of the first angle. Well, the sine is opposite over hypotenuse. So the square root of 1 minus x squared, all times the sine of the second angle, which is 2x. So what do we end up with? We have x root 1 minus 4x squared, all minus 2x, because I'm going to put my monomial in front of my radical, 1 minus x squared. Now, the radicals don't match, so we're done. That's all you can do. That's as far as it will simplify, and that is the cosine of these two angles, the sum of these two angles. There's our final answer. Kind of crazy, isn't it? Okay, so we've done all kinds of stuff. We've done verifying, we've expanded those formulas. Now let's use expansion to solve. Whew, we're going to solve it now. So we've got this equation. We're subtracting a sum and a difference to get root 3. So guess what we have to do? We have to expand both of these out, collect our like terms, and then evaluate. So let's start expanding. Sine we know is sine, cosine, same sign, so we're going to add cosine and sine. Okay, so first half, we're done. That's the first expansion. Then we're going to subtract the second whole expansion. Well, this one's sine x cosine pi halves. Same sign, so minus cosine pi halves sine x. Oh, that's a lot of stuff. And then it's all equal to the square root of 3. Now, let's evaluate what we can. Well, we can evaluate all the ones that are sine and cosine of, I've got that last one backwards. Y'all didn't catch me. Let's fix that one. So this is going to be cosine x sine pi halves. See, when I'm not in the classroom, there's no one to catch my mistakes. Okay, so now let's evaluate the 4 terms we can evaluate. Well, what's cosine of pi halves? Well, that's 0. So we've got sine x times 0. That's just gone because that's 0. And then we have cosine x times sine at pi halves. What do we know sine at pi halves is? 1. So 1 times cosine x is just cosine x. Well, that turned out nicely. This whole side ends up just being cosine x. Now we're going to subtract this entire quantity, so we have to be careful. Sine x of cosine of pi halves. Well, didn't we just say cosine of pi halves is 0? So this part is gone. And then we have minus cosine x times sine of pi halves, which is 1. So we have a negative cosine x inside here. Okay, so what have we actually got left? We have cosine x minus a negative cosine x. Well, that double negative is just a positive. So that's going to be cosine x plus cosine x. And let's bring down our radical 3. I forgot to do that on the last line. Let me go back and be a good math teacher and do that. Okay, so what does that give us? That gives us 2 cosine x's is equal to root 3. Divide both sides by 2. So where is cosine x root 3 over 2? Ah, well, on the unit circle, we know that's the long one here, and it's the long one here. So guess what our 2 answers are? Pi 6 and 11 pi 6. And those would be the 2 answers on the intervals 0 to 2 pi. Now, if we wanted general solutions, remember we're adding to those a circle. So we would take pi 6 plus 2 pi n and 11 pi 6 plus 2 pi n. And that would be our general solutions. Now, we were asked for just those on the unit circle, so these are the only 2 answers on the unit circle. So, are we ready? Ooh, that was a lot. So, main thing, read the problems really carefully. Make sure you know what you're answering. We're going to work on Unit 7, Worksheet 1 and 1A. The only reason I have them separated is the 1A comes out of the textbook. It's got textbook pages. So if you need to look up some more examples of sum and differences, use the online text to help you. that can supplement the videos if you need some more help. So all we're going to do is sum of difference formulas today and tomorrow, kind of get started on these before we take a break. So let me know if you need help, and thank you for watching.